So let's go to the first set of slides and start our introduction, which covers only chapter 1 for today. So I'll click on the slides and I open it. And of course, once you have access to the website, you can review the slides in combination with the textbook. Some of these tables come from the textbook. So let me just try and make that a little bigger. Something like that. So our introduction is not going to be very complicated, I don't think. So we're trying to just set up sort of a foundation for how we talk about information and how we will represent the information. So some terminology. We have the words variable, value, and score. If we're looking at something by way of a survey or whatever, it could be stress level of a person, or the age of a person, or gender, or religion, or whatever. We have what's called a variable, some characteristic. And it could have different values. Stress levels could have different values. Age values, gender values, female. We call that a variable, something that can have different values. Values then, all the possibilities for that variable. If I'm looking at age, and then the values are a set of possible numbers. For when I survey a person, what could I possibly get? When I now actually look at a specific individual, their age value or their stress level, whatever the variable is, just to separate that from the idea of a value, we'll call that a score. So that's when I look at a specific individual. Their value is called a score. A particular person's value on a variable, whatever I'm investigating, whatever the variable may be. So then, I have different kinds of scores. I have different kinds of values. If I'm looking at something that will result in a number, like the stress level or the age of a person or the height of a person or something like that, it goes by many names. The book here calls it an equal interval variable in a way, or just an interval variable, or a scale variable, or just something that's a numeric value, like age or height, or something like that. I get a number as the score of a person. Whenever I survey someone, I'm going to get a number. That can be anything within the range that I'm looking at. Then another type of value that I can get, another type of variable, is a rank or order variable, rank order variable, where it comes from ranking my people, like or my individuals. If I look at the class standing, if I rank everyone in class, then someone will be first, second, third, and so on. Yes, it's still a number, but it's not, they're sort of connected, giving me an arrangement, a ranking of the people. So it's a little different than the first one. And as we look at actual examples, these will become more clear once we get to the later chapters. Anything that has a ranking to them. The position for how people finished in a race, there's a ranking. So it's a little more structured than the equal interval, the numeric variables in general, because they're sort of linked together. If someone's first, no one else is going to be first in general. So there's a little bit more information that's captured in this. So we'll handle them differently sometimes. Then I have the other side of the numbers where I just have categories. I survey gender or religion or many other different things that the values fall in different categories, and it's not a number, male or female, it's not a number. So we'll call that a nominal variable or a categorical variable, where the values are different. They're not numbers. They're just words indicating the different categories. All right. Then, so for many statistical procedures later on, it will be important to differentiate between these two, because we'll do different things depending on the type of variable that we'll get. The other side, or the last thing, is the difference between a discrete and a continuous variable. Now, for our purposes, it's not going to be too crucial, but it's good to, from the start, be aware of the difference between discrete and continuous. So when I look at a discrete variable, it has technically a finite countable, well, it doesn't have to be finite, a countable set of possible values, like the number of siblings a person can have. It's not just any number, they can't have 1.5 siblings. They have just integer values, 0, 1, 2, 3, and so on. We call that discrete. Versus continuous, if I look at the height of people, that can be any number, decimal number, within a range of realistic height values. I can't necessarily count them because I can have any number in between. Or another example is the distance from the person sitting next to you. If you actually take out a measuring tape, that can be any value. You can't just make a list of possible values. It can be anything in a range, depending on how accurate your measurement is. So just be aware of the difference in this kind of difference in the values of variables, discrete versus continuous. So nominal or rank order variables are discrete variables. I only have a certain set of categories, and I can count them off. I have a group of people that I'm ranking, or objects that I'm ranking. I can count them off, the different possibilities, the different ranking values. Whereas the equal interval variables, they can be both. It depends on what I'm looking at, but any continuous variable will sit in here. But if I'm measuring something else, like stress level, if I'm working on a scale, it could be either 0, 1, 2, 3, 4, 5, then it's discrete again. So it depends on the variable in question, but these bottom two guys will always be discrete. Only a countable set of possibilities. So if I look at something a little bit more specific, like the stress rating for a collection of people, I think we have 30 people surveyed in this example. And of course you can read the detail, a little more detail in the textbook. The slides and the lectures just serve as an introduction. You have to sort of fill it in by reviewing the textbook. So 30 people were surveyed, and we have different stress ratings ranging from 0 to 10 seems to be the highest. 0 meaning low stress and 10 meaning high stress. How do we, if we just list the results like this, it's really hard to make any sort of sense and draw any conclusions from that long list of numbers. And 30 might not even be a very long list. We want to just organize this and present this a little better. So we can do that by way of a frequency table. I'll leave the numbers up there. So my different possibilities are in the first column here. It ranges from 0 to 1. Then I'll put it in increasing order, just to structure it a little bit. And then I have to go and count. How many times did a 0 rating occur? Well, I look at my list. Hopefully it's a manageable list so I can do it by hand. I only see this one guy. He was stress-free. So it has a frequency or a count of 1. And I look how many times does a 1 occur, 1 again. How many times does a 2 occur? Look at my list, only once. There were a couple of 3s, 4, a couple of 5s, 4 6s, 7 occurred 7 times, and I go through the list, counting how many there were. So if I add up all the frequencies, I have to get the same number as the total number of people surveyed to make sure that everyone was counted at some point. Everyone's counted here and everyone's counted exactly once. These categories, if you will, these possible values of the variable, they don't overlap in any way. So any one observation falls into only one of these rows. So I have a little sort of check that if I add up the frequencies, it has to give me 30 as well. 30 people were surveyed. So the key concepts here are frequency, frequency table, or I also call it a frequency distribution because it tells me how the values are distributed across the different, how the observations are distributed across the different values of the variable, the different possibilities. It's distributed, and if I look at this, I see, oh, here it increases a little bit. I didn't get too many 0, 1s, and 2s. Once I go into 5, 6, 7, I get more people here. So it just gives me an idea of where the more common values sit. And I look at how the frequencies are distributed over the possible values. I can look at it just as a frequency number, or I can also look at it as a percentage. So how do I calculate this 3.3%? Well, I would have to have the total number of people. That would be a 30. So I would go, I get one person that has stress rating 0 out of a total of 30, and I just multiply it by 100 to get a percentage out of that. And I'll get 3.3%. And I can do that for all of them. Sometimes a percentage is a little bit easier to work with. I feel more intuitive toward it. Yeah, percentages feels more intuitive when comparing this column to this column. I feel a little better about percentages for some reason. We're used to talking about percentages. And it's easier when I'm trying to compare different frequency tables using the percentages. So these two would agree with each other in that the stress rating of 7 is the highest, has the highest frequency, and therefore also the highest percentage. Percentages. So I have to go in increasing order, listing all the values of the variables, giving a heading to my different columns so I know what I'm doing, presenting it effectively, and make sure that I'm counting everything that there is. By adding up the frequency column, it has to give me the total. And if I want to do percentages, or depending on the question, I can do that. Any questions so far? Day one, I know it's not overly complicated, but I also don't want to go too fast, since we're just getting into things and mentally preparing ourselves for what's coming up. So let's just look at a couple more examples. This one was a survey where the question was asked, would you prefer to live out in the country with not many people around? You can ask yourself, well, what did you answer? This was an example survey of 110 people. It's a little tedious to go and count them. 110. Where the possible values for this variable ranges from, or the value ranges from 1 to 7. Not at all do I want to live out in the country, to yes, very much. So I get the survey results, and I can summarize that in a frequency table. So here I just give a name x to the variable in question. So the possible values are 1 to 7, and f for frequency. This is maybe not the best idea to give headings like this, it's not quite clear. Use words here. Variable values, frequency, percentage. So that anyone that reads it would know exactly what your columns represent. And then I go and count. It might take a little bit more time. The bigger my collection of survey results, the longer it'll take. And I see these frequencies. So a frequency of 4, which is sort of in the middle, occurred way more often than anything else. And the corresponding percentages, by just taking, for example, 30, dividing it by 110, would be 26.3%. So if I compare this way of representing the information versus this table, I think everyone would agree that the frequency table is a much more clear way of representing the information. I can immediately make better conclusions from it by saying, oh, most people, it seems, were sort of moderate or around moderate, 3, 4, and 5 level, where they don't really seem to care whether they live in the country or not. They don't have strong feelings either way. Any questions so far? Does all make sense? If you feel that it's too easy, it's good. That's what I'm aiming for. People have this misconception that statistics, oh, it's hard before I even started. I've sort of mentally already checked out. It's going to be hard. But if I build it up correctly and sort of have a big picture in mind, it's really not. So this example, horn honking example, where we measure how quickly people tend to honk at the driver in front of them if they don't move, sort of measured in seconds. So the results here are just made a little bit nicer. So it only goes in half-second increments, but in general it could be just a variable that can have, it could be a continuous variable with any possible value, depending on how accurate you want to measure the time. So I get those results. How many were there? You can count them easily. And let's summarize them with my frequency table. So one way to do that, if you have to do it by hand, it's a little tedious, but it helps solidify the concept by, if I force myself to do it by hand. Will you eventually, in general, do it by hand ever? No. I would use something like a spreadsheet or SPSS or something. But if we jump to this too quickly, we're sort of detached from the concept. It doesn't have time to sink in. So doing it by hand, we could just list the possible values and then just do a little tally marks for whenever I see 0. I get one of them and never again. So I'll have 1 here. When I get to a 2, I notice it 3 times as I go through the list. Oh, 3.5. Mark off 1, 3.5. Oh, a 2. Mark off 1, 2. Then the 0. Then a 5. I'll mark off the 1, 5. And eventually I'll go through my list. And then I just see how many times did each one occur, giving me the frequencies. So I see here that the majority of people were in this range over here. 2.5 to 4 seconds. And you can think to yourself, if someone doesn't move and the light turns green, how long would you take to let them know? What kind of person are you? Half a second. Go. Don't know. So, depending on the In this case, because we're measuring just time in seconds, it could have many other values here, not as clean as this. So it might also make sense to group them together, because if I have too many different values, 3.5, 3.6, 3.7, 3.8, 3.75, how accurate, depending on how accurately I measured the time, I could have many, many values here. And it might be too many. I don't want my frequency table to be too big. So the alternative is to group them together. Whoops. Group them together, where I can decide on, let's look at second intervals. Length 1 second each. So let's say we stop at 0.9 or 0.99, then 1 second to just before 2, and so on and so on. The first second, the second second, and so on. And then, depending on how we choose our groupings, the frequencies might change. It's still, all the information is still there, but I've decided to have a smaller frequency table by grouping some of the values together. But the frequencies still add up to the total. So it depends on what values I have. Maybe grouping them. I don't want this to be too big. I don't want this list to be too long. So just be aware that I can group them together as well. Especially if I have a variable that's continuous and have many different values. I really have to group them together so that I can have a discrete set of possibilities here for the frequency table to be a little easier to read. So what are the steps? Let's just emphasize the steps for making my frequency table. Here, let's read this together. I want to make a list for each possible value or each possible grouping that covers all the values in the case of a continuous variable. And then I'll go one by one through the scores, the actual values that I get from the survey, and count which value or group it corresponds to, getting the frequencies. Then just make a table with nice clear column headings to summarize those results and calculate the percentage if you want to, or if the question wants to. Yeah?
I say we're doing this for our quiz. Do you want us to show you everything we do, for example? Okay.
No, for a quiz, if you are asked to make a frequency table, it's only the end result. Some
Okay.
people might do the tallying, some people might just do it in a different way, whatever comes naturally. It's only the end result. Yeah.
Okay.
And the nice thing about this is that you can have it checked. You know when you're right or not. Well, it's not a guarantee that you're right, but if you add up the frequencies and if they don't add up to the total number of scores, then something's definitely wrong.
Okay.
If they add up correctly, you're probably right. So it's fairly safe in that way, but it's only the end result. We can also do it graphically. Some people, in fact, probably most people, are visual, and yeah, a list of numbers might look good to me, but maybe not to you. This frequency table and this graph that we call a histogram, they represent the exact same information. But you can decide which one shows the information better to you. It's a subjective thing. That's why it's good to know different ways of representing the results or the information, so that different people can understand it just as easily as you do. Some people are happy with this column of numbers. Some people prefer the graphical version. So it's good to do the graphical one, for sure. And when we're graphing the frequencies, be it the actual frequencies or the percentages, this could be percentages as well, 0 to 100, or whatever the maximum percentage is. The shape here will be the same. these heights will still be the same relative to each other, whether you use the actual frequencies or the percentages, and we call that a histogram. So it's a bar, each grouping or value here has a little bar associated with it, centered at the value, with the height corresponding to the frequency or the percentage, whichever one you prefer. So 3 here occurred 2 times, so it has twice the height of the other 2. And it sort of gives you a profile or a distribution to see right away which values occurred more often, and not just that, also how much more often. Then you can have just a visual assessment. The 7 appeared way more often than a 4, just by comparing the heights. So it's just a little easier to look at a histogram versus the frequency table of numbers. So the one thing with a histogram is, these are my possible values that I can get. There are no gaps between the bars for these numeric variables. Because I go from 0 to 1 to 2, there's nothing in the middle that I missed. So these bars all touch each other. Histogram. That was for the stress rating example. If I just represent it graphically, by way of that graph, I'll get that. If I look at the stress rating examples by using a grouping, maybe I feel that 10 or 11 different values were too many. I want to group them so that I have a more manageable, smaller list, easier to present. So I'll put 0 and 1 together, 2 and 3 in a grouping, and so on. Then the frequencies look different, even though they still add up to the total. And my profile, my histogram, looks a little bit different. It's the same information, it's just grouped together in a different way. It's still centered around the 6 to 7 range is still the highest. So I can play with groupings and see which one is representing the information in the best way. Still the same information. So that's a histogram. So I have the steps here, 1 to 4. I have my frequency table. I look at my different values on the horizontal axis, my frequencies or percentages on the vertical axis, and then I just look at the heights and make little bars accordingly. Alright, histogram. So if I look at the living country example, where people indicated how much they wanted to live in the country away from everyone else, I have my frequency table on the left there, and the profile for how the frequencies are distributed would be represented by the histogram. And then right away, people in general don't really want to look at too many numbers. Because they believe numbers are confusing, they're going to look at this and get confused. So graphically, there are very few numbers here. They don't need to look at these numbers. It shows right away that the middle rating is by far the one that occurred more often. And you can easily conclude that in the sample of people that were surveyed, most of them, or the result that came up more often is the one where they really care. They don't have strong feelings either way. So the histogram has a clear benefit that it shows the information without people having to be caught up in the numbers and get confused. Even though the information is exactly the same. And you can go from the histogram to the frequency table. All the numbers are there, they're just not shown for the sake of effective presentation. Any questions so far? Remember, if you don't have questions, then we're going to be done too early for our introduction. You can't always wait. You want to be finished early. But the introduction often happens like that. Because it's not overly complicated concepts. whoops, that's too far. 1.9. I'm going to look at my horn honking example, measuring how quickly people get on the horn when someone's not moving in front of them, and they should. You can decide where you fall. I'll probably fall in this first group. Maybe you fall in the last group. You're like, yeah, whatever, we can stand there all day. It shows, hopefully, my 29 people or cars sort of represent the population in general. And eventually what we're trying to do is we look at a small set of people and hope that they sort of represent what people would do in general. And later on the tests are all about how confident are we that my 29 people that I surveyed represent the whole population. And can I conclude that, oh, here I see, between 3 and 4 seconds occurred more often. Can I then go and say, oh, people in Canada would react in the same way? A large portion of what we'll do is really that sort of jump from a sample, just a small collection of people, to making conclusions about the whole population. So here I have all the numbers. I group them in 1 second intervals, just so that my frequency table is nice and short. And I see a nice profile here that clearly shows all this information, that in the middle, this is what I would expect. You don't find the majority of people on either extreme. Even though you might sit here, the majority of people sit somewhere in the middle. They're not going to wait too long, but they're not going to be too fast either. So the histogram is wonderful for just showing the information right away without having to refer to the actual numbers and frequencies at all. They're still there. I can still look at, oh, well, how often did this happen? Oh, 11. How often did this happen? Oh, 7. And I can recreate this from the histogram. But you don't need to if you're just trying to sell the information, convey the information. All right. So, steps for making a histogram. I don't necessarily want to memorize this without thinking about them. First, if you just think about what you're trying to do, these 4 steps should come out in a logical way. So it's not really a question of memorizing them as much as just understanding what I'm trying to do, what would be reasonable steps to get there. So I have to now go from my frequency table, which could be either listing the different values or groupings, depending on what I want to do to have a manageable size table. Then I make put the values along the bottom of the page from left to right. I'm making my horizontal axis according to the values or the groupings, and then my vertical axis according to the frequencies, but I can also graph the percentages, and then just make a bar for each frequency that I get. Nothing to it. And when we get to SPSS later on, we'll see what the steps are in SPSS to make that histogram as well. Because if I have a large collection of survey results or many options for my frequency table, then it's not reasonable, it's not practical to do it by hand. So we're doing it by hand so that it solidifies the concept, but we're also going to be aware of how things are done in general. That is 110. How do we make a histogram? We don't have much left. I'm going to stretch this out. Other lectures will be fuller, I guarantee you that. So, the other type of variable is the nominal or categorical variable, where I'm reviewing people, for example, who's the closest person to you. And the different options in the multiple choice survey will be a family member or a non-romantic friend, romantic partner, or someone else, just to cover everything. So anyone will pick one of those four categories. So the values of the variable are these. They're not numeric. It's a nominal variable, different categories. And I get those frequencies, and I can calculate the corresponding percentages. When I'm graphing or representing the frequencies graphically for a nominal variable, then we don't call it a histogram, we call it a bar graph. And because it's not numeric, I don't go from one to the other with no gaps. They're separate categories. So then there are gaps between them, just to separate them. And it's just a matter of sort of the convention to do it this way so that someone can look at this, someone on the other side of the world can look at this, and if it's a bar graph, oh, it's a nominal variable. They might be calling it something else, but you quickly see the difference. So the difference between the histogram and the bar graph should show the difference in the type of variable that I'm investigating here. In this case, I have those four categories, but the basic steps are the same. On my horizontal axis, I put the different names for the categories, the values of my variables, and then according to the frequencies, I'll have the height again. So it still visually represents the information, conveys the information just as effectively as a histogram. It's just a different type of variable. Where we see here, oh, these middle ones, the friend or romantic partner was the most popular pair of choices. Any questions on that? Okay, so the last thing is just to be a little bit aware of the type of profiles that we can get from our histogram, bar graph, whatever it is. The first one is the mode, where the mode refers to the value that occurs most often. And if I look at examples, we're going to do examples in a second. 1.8, slide 1.8. If I look at this profile distribution to the histogram, I see there's one value that occurred most often, and the others were sort of the same. So it has a single mode of 4, the value that occurred most often, and we call this distribution unimodal. It has one mode. If I go back to 112, I could also have something that has a couple of values that occur not necessarily exactly at the same frequency, but much higher than the rest. Then we call that bimodal, or approximately bimodal, 502. Slide 113, something like this, where, that's interesting. If you look at a toddler's play area, what is the profile of the age of people that are in that area? Well, they're either kids or their parents. So it has a profile with 2 peaks. 2 values might occur often, or 2 groupings of values. Approximately bimodal, there are 2 modes. Just jump around here for a little bit. Or I can have something that doesn't really have anything. Nothing really stands out, and it's fairly flat. It doesn't have to be perfect. So it's fairly flat. We call that rectangular or approximately rectangular. There's probably an example on the next slide here, where if I look in a school with fixed class size, let's suppose the school is fairly full, then each grade will have a similar number of students in the classes. So there isn't one that's really standing out. It might not be perfect, but it's sort of pretty level. there's no mode, there's no one value that really pops out. Okay, the next one is the idea of skewness. Skewness. Is the distribution, or the profile, sort of nice and centered, at its highest peak at the center, symmetrical, or is it sort of shifted to one side? If it's sort of shifted to the left, look at where my examples are. Yeah. If it's shifted to the left, the peak is on the left and then has a longer tail towards the right, then we call that a positive skew. And if it's the other way around, where the peak is on the right of the center, and it has a longer tail to the left, then we call it a negative skew. So do whatever you need to do to memorize which one is which. To me, it feels a little counterintuitive for some reason. The long tail on the right, that's the positive side, positive skew. The long tail on the left, negative skew. Just to indicate, what does the profile look like? So if I have some examples in 114, our examples were fairly symmetrical in that the peak was sort of in the middle, but I could have something else like number of families with a survey of number of children. How many children does the family have? Over many families that are surveyed, you get many families have 0, 1, 2, and then if the number of children increases, then that happens less and less often. So I have, what kind of skew would this be? Positive or negative? Positive. Positive skew. So the tail is to the right and the peak sits on the left. Positive skew. Or if I look at the example on the right there, if I look at the percentage of right answers in the quiz, and I look at how people scored, depending on the quiz, you could have something like this, where many people scored fairly high, and then fewer and fewer scored low. That would indicate negative skew. The most common value sits to the right of the center, and then it sort of drops off to the left. So it's just a way of referring to the different distributions, the different kinds of profiles that we can get by way of words like the mode or the skewness. Any questions on skewness? So in SPSS, we were not really working with skewness and things like that too often, but that it can measure, there's a way to measure the skewness and give you an idea what it looks like without having to do it by hand. And we'll look at that later today. The last one is kurtosis. That has important information in terms of how narrow or wide the distribution is and, compared to a normal sort of shape. If I have a more peaked version, then it's sort of narrow around the mode and it drops off fairly well, I can't really say how it drops off. It's more how narrow it is. Meaning that I don't necessarily get a lot of values that are too far away from that center most common value. It's not spread out as much. It's a little narrower. Or I could have something that's a little flatter, more wide, I guess. If I compare B and C, meaning that I get some variation around that center. It's not all just packed close to the center. I'm not going to see many scores that deviate from that too much. There's a fair bit of deviation that happens fairly often. So right now I'm just getting used to the idea that there are different things that, different properties of the distribution or the profile. How many peaks it has, how one-sided it is in terms of the skewness, and sort of unbalanced left or right, and also how narrow and wide it is. It tells me something about the properties of the variable I'm investigating. So 115 is an example. So here, that was, oh, it's a separate example, where the survey question was, are you made uncomfortable by loud noises? And the results, which you might expect, show that most people are not doesn't have any strong feelings in either direction. They're sometimes bothered, but not too much either. So you get some scores on either side of that more common value, but you don't get much deviation. The vast majority of the scores are that middle value. What do we have here? Here we have a much flatter distribution. Where are you close to your father? Sort of everyone gets, it's sort of spread out in terms of the results that you get in the survey. There's no one peak that stands out. So it's an important property of the distribution in terms of the shape. Do I get something that's spread out? And it's not really, yeah, 4 comes up more often than anything else, but only slightly so. I can't say that if I just randomly pick one of those people, do I expect to get a 4? No, it's pretty spread out. Whereas if I randomly pick one of these people, do I expect to get a 4? Yeah, I do, because that's by far the more common value. So I have 3 different properties of the distribution. The mode, and how many different values are most common. The skewness, how does it set left to the left or to the right, or nice and symmetrical, as well as the kurtosis, how narrow or spread out it is. That tells me what I can expect. It's a property that if I look at something like this, and I assume that this survey is representative of all people in the country, if I then go and randomly pick a person, I can expect that person to sort of be in the middle when it comes to loud noises. I don't expect to find many people that are not bothered at all or extremely bothered. Whereas if I look at this result, if that is representative of the population, the fact that it has this spread out property tells me that there's really no, I get any kind of result when it comes to this question. If I randomly pick a person, I don't really know what they're going to pick. They can pick anything. I have no real indication that there's one response to this that stands out more than others. So these properties help me to say more about what the variable is and what it represents over my sample or maybe the whole population. Are there any questions on this? So this is very much an introduction. We're not getting into any technicalities apart from frequency and percentage. There are no real fancy calculations. And that's done on purpose so that we can just ease into things, make sure we can get to the website, make sure we understand this. This is really the key to success, I feel. If you skip one thing, or let's skip this. If you skip this additional example step, then you might expect the quiz to be a little bit less clear. But if you've worked through the additional examples first, then you'll see the quiz is actually very straightforward. It's an additional example with different numbers. If you work through the SPSS examples, then you'll see the homework is really very straightforward. It's the same question with different numbers. So there's a correct way to build up your understanding so that you can get all your marks as we count them. Any questions?